Hello, today we're going to talk about heat transfer and thermal equilibrium. Let's review the relationship between temperature and kinetic energy really fast. So temperature is a measure of the average kinetic energy. So that just means you're going to have some particles in your sample will have a much lower energy and some particles have a much higher energy, but the average is what we're looking at when we have a temperature. So on this graph, there's three lines, red, green, and blue. Red is the lowest temperature of those three. You can see that the average is kind of indicated by where the peak is. And these are Maxwell-Boltzmann distribution curves. And the blue one is going to be at the highest temperature. The average, the peak there is larger. You'll see that there is a larger distribution of different temperatures at the higher, larger distribution of different energies at the higher temperature sample than at the lower temperature sample. So let's take a second and talk about heat transfer. Heat transfer is the transfer of energy due to a temperature change. So whichever thing is at the higher temperature will give some of its energy to whichever thing is at the lower temperature. And the energy that's transferred is called heat. And this transfer continues until both substances are at the same temperature or the same average kinetic energy, and we call that thermal equilibrium. So let's look at an example of this. If you have 50 grams of aluminum with that specific heat capacity at 85 degrees Celsius, it was placed into 100 grams of water at 25 degrees Celsius. What happens to the temperature, average kinetic energy, and average speed of the aluminum? So the aluminum is at 85 degrees Celsius, and it's going into water at 25 degrees Celsius. So aluminum and water. The aluminum is at a higher temperature than the water. So the temperature of the aluminum will decrease as it is transferring energy to the water. So the temperature will decrease over time. The average kinetic energy, therefore, will decrease over time because they're the same thing, essentially. And then the average speed of the aluminum will also decrease because if you have a lower average kinetic energy, their particles will be moving at a lower average speed. And of course, this will continue until they're at the same temperature. Okay, for this example, we have aluminum again at 85 degrees Celsius, water at 25 degrees Celsius, and when you put them together, the final temperature is 30.8. So what can be said about the temperature changes for each substance? So we can say that the aluminum decreased in temperature because it was giving off heat to the water, but the water increased in temperature because it was gaining heat from the aluminum. Now the temperature changes were not equal, and that's really important. Temperature changes were not equal, and that has to do with the difference in the specific heat capacity, which we're going to look at in the next section. But what's true about the amount of thermal energy exchange? It must be equal, all right? And that's what this section is all about. The heat that is lost from the aluminum is equal to the heat gained by the water. That must always be true because you cannot just like have energy disappear or energy be created from nothing. So the thermal energy exchange must be equal.